Hello. And in case you're just joining us, this is Chemistry in the AM in progress. Jot this down, balancing redox equations. We have one easy example and then we'll go with it. Yesterday we did half reactions. Now we're going to start to take a look at two reactions together, how to split them apart, etc. All right, so you've got this down, I'm hoping. You have the back sheet at the back of your handout set, right? Okay. So this easy example, this is easy because it doesn't involve hydrogen or oxygen. So the acidic solution here, we assume acidic solution unless you're told differently. You see what I'm pointing at with my fingers, can't see it on video. So, one, separate into two half reactions and balance what you can without worrying about oxygen or hydrogen. That's what it's simple as well as hydrogen. So to separate it to two half reactions, we go, well, the copper and the copper. These ones are pretty obvious. Copper, arrow. Line up your arrows with the pre-existing arrow. This one. I'm leaving space in front of the number or in front of the elements and the ions in case I have to. The other one's pretty obvious too. The iron goes to iron. Okay. So we've separated into two half reactions. And there's one copper on the left, one on the right, one iron on the left, one on the right. That's step one. We balance what we can. There's nothing to balance. So we're worrying about oxygen and hydrogen. Step 2 and 3, since we don't have oxygen and hydrogen, we skip straight to 4. Balance for charge by adding electrons. So this is the purpose of the easy example, since it's electron. So I'll do them one at a time. This copper is an element, so no charge, 0, right? This one is 2+. We always take the higher side and bring it down to the lower side because we're adding negatives, we're adding electrons. So 2 is up here, 0 is down there. We've got to bring 2 down to 0. So we go, how many electrons? How many negatives? So we will go with that. 10. We need them on this side. So that when I add up 2 positive with 2 groups of -1, that's 0 to match the left. I know yesterday with the half reactions, that could add. Does it always just add up to 0? No, it's the most common one, but whatever's the lower. And in these two examples, it's 0. So doing the same thing on the other. We got the high side is on the reactant side, the left. This is a 0. So to bring the high side 3, we need 3 electrons. So I'm going to put 3. Okay. That is step 4 on your steps, which you will have on an exam. We just have to know how to do it. So balance for charge using left. Each of the half reactions are balanced, but they're not balanced overall. And step 5 is add them. So I'm going to just draw a line here. And keep the arrow lined up. This way we can see when it gets more complicated, especially one crosses out. So step 5, add the 2 half reactions, canceling out or combining any repeated species. I say species because some are elements, some are compounds, some are molecules, some are ions. So species just includes any. Note, you should not have any electrons left after this. You may have to multiply your half reactions to match electrons from the reduction and oxidation half. We do have. You see that this half reaction spits out 2 electrons. This half reaction, in this proportion, takes in 3 electrons. That's not a match. You have to have as many electrons going in as coming out. It's certain. So, this is like adding fractions. have this skill. What do we do to add 1/2 plus 1/3? Well, multiply the half by 3, and then the third by, you multiply by each other. It's called the lowest, you guys know it, lowest common denominator. It's the same skill. So I'm going to just switch here, and we're going to multiply everything on the top equation by 3. I'm going to just write it down there. And then, now, normally, I just write over top of these, or whatever. This is what I'm thinking, right? I'm going to erase those times 3 and times 2. I don't care. Keep them there. I'll just move them. As long as you know, I put them in a circle so you know they're not part of the equation. So I'll go at the top equation. I won't erase them. So if I multiply everything by 3, that's 3 times 1, 3 coppers. 3 copper ions. 3 times 2, 6. Leaving space, that's why I did that. Do I have to adjust? Likewise. Now, if you're doing this, put a neat line through the crossed out 2 or the 3, so that if you make a mistake, I can see what was going on in part, right? It's more of an insurance policy. Times 2, times 2. Then, you notice that some things cancel out. The electrons. If you've designed this properly, the electrons always cancel out. Half reaction above, 6 electrons thrown out. The reaction below, 6 electrons taken in. By the way, this is a good application of that little memory aid, oil ring. I didn't ask for it, but which one is reduction, which one's oxidation? Oil. Oxidation is losing electrons. Which half reaction, top or the bottom, is oil? Oxidation is losing electrons. Which one's throwing them out? Which one? Top or bottom? Actually, it's top. Because they're leaving, they're exiting on the product. The oil, I'm going to just put this here as just a figure thing. This is oxidation. Then rig, this must be reduction. But why is it reduction? Reduction is gaining electrons. You're adding them in. So this is my reduction. So I'm going to cross them out. That's important. Once you've done that, that means when we add these up, we will have balance for both atoms and charge. So I'm going to just go 3 coppers. The other thing on the left side is now 2 iron. 3 copper iron plus 2 iron. And if I look at this is balance for atoms. That's no doubt. You quickly see 3 copper, 2 copper, 2 iron, 2 iron. And then the charge-wise, this overall reaction is 2 times 3, that's 6. This is 3 times 2, that's 6. This is simple enough, you could have done it. But we're starting simple because we're going to get complex. I wouldn't suggest doing those. So, but first we're going to try these easier ones. Yeah, absolutely. And on that worksheet that I gave you with the, where I literally copied and pasted it on the textbook, pick that up because I just showed you which one. It's labeled 632, 1A and B. Okay, you're doing those. I'll pause the video. You guys have work time to do 1A and 1. Okay, we just went over 1A. I'm going to re-talk it. It was fairly simple. There's the solution. We're going to go to 1B together. So splitting into half reactions, that was self-explanatory. This time, I look cobalt, cobalt, 1 to 1. Nothing to balance before we start. Iron to iron, iron, nothing to balance. So atoms are balanced. There's 2 and 3 skip if you run a hydrogen or oxygen. So I'm going straight into the electrons. In this case, cobalt is 0, The high side is 2 plus for cobalt ion. Right? So to bring 2 plus down to 0, I need to add 2 negative electrons. Iron goes from 3 to 2. Here's another example of high side 3, low side 2. I need to bring the 3 down. So I add 1 electron. Now I've balanced each half reaction for charge and atom. Incidentally, it wasn't asked, but I will practice. Oil rig. The first half reaction is cobalt 2 plus 2 electrons. 2 electrons are being thrown out. They're leaving the system. So I say oil rig, oxidation is leaving, or losing electrons. So this is oxidation. This has to be reduction, but why? Because we're adding electrons. Reduction is gaining or adding electrons. Rig. All right. Well, rig pig like you, right? We should have a show called Rig Pigs, right? But it's like a little pig, not like a teacup. And I could be the host of that, and then sometime we'll have a joint episode. Yeah. Blues Clues, Blue and Little Riggers. Yeah. It would be all kinds of things. That'd be so cute. Anyways, back to this. Okay, I'm ready to cross an electron. Am I? No. We don't have the same amount of electrons. This is an easy one. 2 electrons or 1 electron, we only have to multiply 1 of the electrons. So I'm going to multiply the bottom one by 2. I'm going to just put this here so you know what I'm thinking. Now put it in a circle. It's not part of the question. Times 2, times 2, times 2. Right? Now, 2 electrons out, 2 electrons in, they cancel. That's what you need. Then I just write down what's left over. Cobalt on the left side, 2 iron, 3 off. Cobalt ion plus the iron 2 ion. There we go. Simple half reactions add together. This is a balanced full reaction. Get ready to just buckle up and feel the G's as we cruise through this. So you have these. Oh, I don't want to do it now. Do I? Yeah, I do. Sorry. So now, in acidic solution, we use. Now this is stuff you have down, so don't rewrite all these steps, right? This is on the back of the sheet. We said acidic solution means you can use water and hydrogen to balance, if needed. Now, we didn't talk about it basic, but you still go through the same steps as if they're acidic, and then there's a last step. You notice we're skipping step 5 because I'm only doing half. If it's basic, as a last step, you add hydroxide. I won't get into that too much until we get to the step. So here's an example in basic solution. We treat it at first as if it's acidic. So separate into half reactions, that first step of balance for things other than hydrogen and oxygen. Well, there's 1 CR and 1 CR. They're balanced. So I still scan and make sure it's not CR2 on the side. So you guys are just jotting this down. Just call it basic. Okay? So maybe put basic example and jot this down and give you a moment. Okay? So, Stuart and I were talking. Well, welcome to Chemistry AM. We're in progress. In case you've just joined us, this is Chemistry in the AM. Welcome aboard after those brief commercial messages. Okay, anyway, now we're following these steps. 2, if needed, balance for oxygen using water. We did this the other day. We were talking acidic, but we're still following this as if it's acidic until the last step. So oxygen. I've got 3 groups of oxygen here. I've got 4 groups of oxygen here, right? So the left side needs another oxygen. Water, H2O, delivers 1 oxygen per molecule. So sure you're double checking what size it is. 6 Browning. No. You're a half gallon door. You're Raven door. 6 points for Raven door. That's a hybrid. That means I get some of the points. 3 Raven corner. Gallendorf is my house. Oh. Okay, you don't have banking. The newts I have, they're copper. Anyways, back to this. If needed, balance for hydrogen using H+. So I look through this. On the left, I've got 2 H's plus 3 H's. I got 5 H. I'm just thinking this, so that's why I'm just putting it in. 5 H. I'm not going to worry about charge. And nothing on the other side, right? So does it make sense? We're going to treat it as if it's we're going to balance using H+. You guys remember your 5 H's? Head, heart, hands, health, hydrogen. That's the 5th H. That's what we got. Okay. I think we're done here, right? It works. So then, balance for charge using electrons. Be careful of this. Actually, not that hard. 0 plus 0. Nothing. This reminds me. Mother's Day's coming up pretty soon, right? Yes. Isaiah, what'd you get in your Mother's Day? I think you got her last year? Nothing? Now she's going to have a matching set, eh? There you go. No. The right-hand side, though, 2 negative and 5 positives come together and make 3, right? So 0 on the left-hand side, going backwards, facing. 0 on the left-hand side, 3 on the high side, right? Right. We need 3 electrons to bring it down. Right? That's 2 negatives and 5 positives. That's what the 3 positives. So this is what you were kind of asking. That's what I thought. There we go. We balance this half reaction if it was a sieve. This is a basic. So if basic and a hydroxide to cancel out any of the H pluses. Now this is balanced at the moment. So if I add a hydroxide to one side, it's already balanced. We got to add it to the other. This is math, basically, right? You subtract X from this side, you got to subtract X from that side, or if you add 5 to this, you got okay. Same skill. So here I go. So I look for this, and I'm going to stack it like arithmetic. I've got 5 H pluses. I'm going to go with 5 OH negatives, hydroxide. This should be familiar, because remember how we think of water often in acid bases? So I think it's HOH, hydrogen ion, and hydroxide. Okay. And I'm going to add it to this side. I'm not stacking it here, because it doesn't. I'm going to just, I don't need plus. I'm just going to say 5 OH negatives, 5 hydroxide. By context, I know that's not 50 H times 5 hydroxide. So I should have left space there when I'm squeezing it in. Now here's what I got to think. I didn't mention nothing. If I have 5 hydroxides and 5 hydrogen ions, that's really 5 waters, right? Sure. Right? I think of that as one thing now. That's why I put it directly. Okay. So one last step here is, look at this. This is really, and this is my thought process, 5 waters, right? And I've got 1 water over here. Which side has more waters? The right. How many more waters? 1 to 5? It's a difference of 4. You guys follow me on that? I'm scanning. Okay, I'm going to just rewrite this, and I'm going to call this a thinking step. Okay, this is what I'm thinking. You should be able to do this in your head once you see, but I will write it up. So I'm going to say think. And I'm even going to choose a old burgundy or whatever. To a colorblind guy, I have no clue. Okay, that color. Back to this, good. So here's what I'm writing out. I'm thinking this. I've got the 5 hydroxides on the leaf, plus the water, 1, 3 hydroxide. Screwed up with the arrow, I'm not in line. This is 5 waters. You guys follow me now? No, the box I put down now is 5 waters. This is where I'm thinking. Okay? But I'm able to do this, and I think you guys are too. Right here, I just see this and I think 5 waters. But I wrote it down explicitly. If it helps you, rewrite it, but I'm not done yet. Remember, 1 water, 5 waters. Which side has more? Right now. We're going to leave that there. So, I purposely, okay, I created 5 waters on the product. On purpose. Those 5 waters. That's what I was thinking. And also, I do this in my thought process. I say, well, if I have 5 waters on the right, 1 water on the left, I can cancel what's, just like in algebra. One of the waters cancels with this, and I'm left with 4 waters. This is what I'm thinking. If you need to write it out, go ahead, but I think you guys are pretty good with this. So this is what you actually answer. 5 hydroxides. CrOH3, CrO4, negative, 4 waters, 3 electrons. Now, you can see I get number 2 from 6.2 parts. 2, 5, and 6. You're going to do it. Right now? They're the same thing. They're basic. So basically, do is you give a day, and then put in the 2 extra hydroxide. Or for the 2 questions, add in hydroxides as the last step. Okay? 5 and 6. Greetings. Welcome to Chemistry in the AM. In case you've just joined us, this class is not even in progress anymore. We are done recording. You guys are working.